This is screencast number 1 for Unit 2, Lesson 1, and I'm on page 70 where it says Representing Data. Your essential question: how do scientists learn from data? And by the end of this lesson, you should be able to use models, tables, and graphs to organize, display, and analyze scientific data. So keep that in mind as your objective as we go through this. Okay, let's turn to page 72. All right, I'm on page 72. How do scientists make sense of data? There are many different kinds of scientific investigations, all of which involve the collection of data. Data are facts, figures, and other information scientists gather during an investigation. Data may be displayed in many different formats, including tables and graphs, and that's what we're going to do for a large portion of this lesson. All right, there are two types of data. There are quantitative data, such as length or mass, which can be expressed by a quantity or a number. And then there is qualitative data, such as color or texture, and it tells about the quality or kind of subject, so it's a description. Okay? The first red subheading that says Scientists Organize Data. Okay? Scientists record data in many different ways. Data tables are used to organize data and also to make it easier to graph data. Data can also be recorded using qualitative means, such as a labeled drawing. Data tables often have two columns. One column lists the independent variable, which is the variable, remember, that is being manipulated in an investigation. It's the one that you are changing on purpose. The other column often lists the dependent variable, which is the variable that changes as a result of the manipulation of the independent variable. Okay? Remember our roof color versus temperature experiment. We changed the color of the roof on purpose, so that was our independent variable, and the dependent variable was the temperature, what happened to the temperature as a result. Okay? Units of measurement, such as seconds or degrees, should be in the column headings and not in the individual cells. So you should have somewhere in your table that tells you what units you're using, and they're typically in the column headings. Okay? All right, if you will look down at the bottom of page 72 on number 5, construct something. The average high temperatures for a 6-month period are listed below. The average daily sales of cold drinks at a concession stand during these months are listed below. Organize the data into a table to the right. Okay, so you take all the temperatures and the cold drinks sold, and you organize it by month and put it in a data table. Okay. Look at page 73. Scientists graph and analyze data. Scientists often analyze data for patterns or trends by constructing graphs of the data. The type of graph they use depends on the data they collected and what they want to know. Okay? First type of graph we're going to talk about is a scatter plot. A scatter plot is a graph with points plotted to show a possible relationship between two sets of data. A scatter plot has a horizontal x-axis and a vertical y-axis. The x-axis usually represents the independent variable, so that's horizontal. The y-axis usually represents the dependent variable. And to show the general relationship between the two variables in the graph, a line of best fit is often used. A line of best fit is a line that is drawn to fit or come close to most of the data points. It does not necessarily connect the data points, okay? It's not, for instance, a dot to dot, okay, but it's a general line that shows a trend. It may not touch any of the data points, just depends, okay? All right, if you look down at the bottom of page 73, it says the graph below shows steps used to construct a scatter plot of the drink sales data from the previous page. Step 1 is to label your axes. Label each axis on the graph with the name of the variable that is represented. So if we go back to page 72, we had two variables. We had high temperatures for the months, and we had number of cold drinks sold. And if we do a little bit of thinking, the number of cold drinks that we sell is probably going to be dependent on how hot it is, okay? Because when it's hotter, people tend to buy more cold drinks, okay? So label each axis on the graph with the name of the variable that is represented. Each axis has a range and scale so that the data can be seen easily. Okay? The range is the difference between a variable's greatest value and its smallest value. The scale is the size that's used for each box or grid to mark on the graph. So that's just something you kind of have to look at your data to figure out what is most appropriate. Okay? Step 2 is to plot the data points. Okay? And then study the data shown on the graph and notice any trends if you have any. Step 3 is to draw a line of best fit. Draw a line that comes close to most of the data points. Okay, the line shows a trend or pattern. Okay. All right. Up on number 6, we're just going to jog back to that. Number 6 says identify which axis of the graph usually represents the independent variable. And I can go back to the reading on page 73, and I know that that is the x-axis. All right, so I'm going to pause here, and I'm going to show you what I got for page 72 and 73. Okay, on page 72, I went and made sure that I highlighted data so that I know that know that definition. I highlighted quantitative data and qualitative data, and I also made a note out to the side that quantitative data is numbers or counting. Qualitative data involves words or descriptions. Think of quantitative, quantity, it's a number. Qualitative, you're talking about something's qualities, you're describing it. Okay? Then, under scientists organized data, I made sure that I highlighted where it talks about the independent variable and the dependent variable. And I also underlined the sentence that said units of measurement such as seconds or degrees should be in the column headings and not in the individual cells. Okay, at the bottom, I took the high temperatures, which is in that little red bubble I made, and the cold drinks sold, which is also in that bubble, and I constructed a table. For instance, February, the average high temperatures was 25 degrees Fahrenheit, and in February we sold 43 drinks. March was 40 degrees, we sold 55 drinks. April, 58 degrees, we sold 60 drinks, so on and so forth. Okay, so I took that information that they gave me and constructed a table. On page 73, I made sure that I highlighted and underlined scatter plot because I need to know what a scatter plot is. I starred and underlined where it talked about the x-axis usually representing the independent variable and the y-axis usually representing the dependent variable. And I also highlighted the sentence in the next paragraph that says to show the general relationship between two variables in a graph, a line of best fit is often used. And then I put out to the side, there's a little note. It says line of best fit is not a dot-to-dot connecting all points, but it's a line that shows a trend. It's a line that shows the general relationship between two variables. Okay. Number 6, which axis of a graph usually represents the independent variable? We said x-axis. And then we look down at the bottom of page 73. Okay. I put a box around my x and y axis. High temperature was my x-axis, and the number of drinks sold was my y-axis, okay? Because the high temperature determines how many drinks we sell, okay? Also, I looked at my temperatures, and it goes from 25 to 93, so an appropriate scale might be 0 to 100, which is what they used. Number of drinks sold, anywhere from 43 to 80. They scaled it from 0 to 100, so all of the points will fit on that graph. You know, for instance, they didn't number it from 0 to 1,000 because we don't have anything above 100. Okay, then they plotted the data points. And then on the last one, they drew a line of best fit. Notice that the line of best fit does not go through all of the data points. It just shows you the trend, the general relationship. And if you notice that as the temperature goes up, the number of drinks sold also goes up. That's the general relationship.